Welcome! In this video, we'll focus on function notation, absolute value part 1. Let's take a look at our first example. Example 1. Given f of x is equal to the absolute value of x plus 3, find f of 2. So in order for us to find f of 2, we'll be using two different methods. Let's take a look at our first method, method 1. The description method. And this method uses the description of the process that is going on to generate the function f. So notice that the first thing we're doing is that we're taking x as your input in order to get the output of absolute value of x plus 3. Now, if we were to describe the process, we can say that the first thing we're doing is to pick a number. So step 1, pick a number. And such number is your input x. Now, once you have x, the next thing that we're going to do is to take its absolute value to get the absolute value of x. So step 2, take its absolute value. Thus getting you the absolute value of x. And the next step is to add 3 to it. So we can get the absolute value of x plus 3. Now that's the description. And we're going to use this method or this description in order to figure out what is f of 2. Now notice here that the input is the number 2. So we can say pick a number. Well, we're going to pick number 2. Then we're going to take the absolute value. So we take absolute value of 2, which is just 2. And we're going to add 3 to it. So we take 2 plus 3, that gives you 5. Therefore, we can say that f of 2 is equal to 5. And that's using the description as the method to figure out this output value. Now, we can actually use method 2 as well to ensure that we did this correctly. So method 2, the substitution method. And what we're going to do to figure out what f of 2 is, we're going to substitute in the input of 2 into this expression wherever we see an x. So notice, f of 2 will be the absolute value of x, but x is no longer there. Instead is 2. So we have absolute value of 2 plus 3. So we can say that f of 2 is equal to the absolute value of 2 is 2 plus 3. And if we add those two numbers, we get that f of 2 is equal to 5. And notice that regardless of which method we use, we get the same output value for the given input of 2. That is, f of 2 is equal to 5, regardless of which method we use. Now, as part of an extension, we can say that we have a point with coordinates (2, 5). Why is that the case? Well, that's the case because your input or x value is 2 and its corresponding output or y value is 5. Let's see another example. Example 2. Given g of x is equal to the absolute value of x minus 7, find g of negative 28. So let's use our first method first. So method 1, description. Now notice that your input is x, and its corresponding output is the absolute value of x minus 7. So if we were to describe this as a sequence of steps, the first step will be to pick a number. In this case, we call that number our input x. Then, let's see what are we doing to the x. Well, notice that we're taking the absolute value, so that will be our second step. Take its absolute value. Thus, we get the absolute value of x. And lastly, we're going to subtract 7. thus getting us absolute value of x minus 7. Now, since we're interested in g of negative 28, the number that we're picking is negative 28. So let's start through the process here. So we have negative 28. Then we take its absolute value. So we have the absolute value of negative 28, which is equal to 28. And lastly, we're going to subtract 7. So we take the 28 and subtract 7, thus getting 21. Therefore, we can say that g of negative 28 is equal to 21. Now, let's use our second method, or the substitution method, to double check our work. So method 2, substitution. What we're going to do, we're going to take g of negative 28, and since our input is your negative 28, we're going to substitute that in wherever we see an x on this right hand side expression here. So we're going to say that g of negative 28 is equal to the absolute value of negative 28, since we're going to write that instead of the x, minus 7. So we have g of negative 28 is equal to the absolute value of negative 28, which happens to be 28, minus 7. So we get that g of negative 28 is equal to 28 minus 7, which is 21. And notice, again, that regardless of which method we use, we get that g of negative 28 is equal to 21. Now, as part of an expression, or extension I should say, we can say that we are given the point with coordinates negative 28, comma 21. Since the input, or x value, is negative 28 and its corresponding output, or y value, is 21. Let's see one last example here. Example 3. Given h of x is equal to the absolute value of x minus 13, find h of 0. So let's take a look at this using method 1, or the description method. Now notice that your input here is x, and the corresponding output is absolute value of x minus 13. If we were to describe the process to generate the function h of x, we can say that the first step is to pick a number. In this case, such number is represented by x. Then, since we already have the number x, we're going to take its absolute value. So take its absolute value. By doing so, we get this expression, absolute value of x. And the last thing we're going to do is to subtract 13. So that's our third step. Thus getting you absolute value of x minus 13. So that's the description of the process. Now, since we're interested in h of 0, we know that the input, or the number that we're going to start with, is 0. So pick a number. Well, we're going to pick 0. Then take its absolute value. So we have absolute value of 0 is equal to 0. And lastly, subtract 13 from it. So we have 0 minus 13, which is negative 13. Therefore, we can conclude that h of 0 is equal to negative 13. Now, let's double check our work by using the second method, or the substitution method. So method 2, substitution. Now, for this method, what we're going to do, we're going to substitute in 0 into this expression on the right wherever we see an x. So we have h of 0 is equal to, notice h of 0 is equal to the absolute value of 0 minus 13. So we have h of 0 is equal to, the absolute value is a grouping symbol, so we're going to use that, or evaluate that first. So we have absolute value of 0, which is 0, minus 13. And 0 minus 13 is equal to negative 13. So we get that h of 0 is still equal to negative 13, being consistent with the previous answer. Okay, so notice that regardless of which method you use, you still get that h of 0 is equal to negative 13. Now, as part of an extension, we can say that we're given the point with coordinates 0, negative 13, since the input or x value is equal to 0 and the corresponding output or y value is equal to negative 13. So this concludes our video on function notation, absolute value 1. Thank you for watching and have a wonderful day.